Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on subset. We have to find out all the possible subsets from a given array. Let's jump into the problem statement, understand it and start solving. Last time we have solved the spiral matrix. You can find it in the list. Today's problem is on subsets. So let's start with subsets. Okay, given an integer array nums of unique elements return all possible subsets, the power set. The solution set must not contain duplicate subsets. Return the solution in any order. So one thing is we do not have to check for duplicate element at least, because all the elements are unique. Now we are given the example. There is an array 1 2 3. Possible subsets are blank or just 1 2 1 2 3 1 3 2 3 and 1 2 3, right? So okay, before we go on and start solving this, please take a minute and think of the approach that you would take to solve this. Ready? Okay. So we are going to use backtrack, okay, because one by one we are going to check for all the possibilities. For the blank case, we can just simply add it in the beginning, and then we start with I think we have solved by now 3 to 4 problems on backtrack, so everyone is aware on how a backtrack generally works. We check for all the possible paths. Let's say I check for 1, and then after 1 I'm checking for 2. Okay, I add it to the solution. Then let's say I was only going for 2 places. I trace back, I remove 2 from my path, I go back to 1, so I remove 2, I go to 1 3, right? Similarly, if this is also one of the paths added, we go back, we go 1, then add 2, then 3, then we add 1 3 2. Similarly, we do this with each of the elements. Okay, so it's a pretty straightforward problem once you are by now well versed with backtrack as of now. So let's start coding. Okay, I'm sure it will be much easier for everyone of you to understand. Okay, let's start. So what do we need first? We need the list of integer called result is equal to new array list. Okay, next we need list of integer current subset, okay, equal to new array list, right? Next, start the backtracking process, because since we want to call the backtracking method again and again recursively, we'll simply use a separate method for backtracking. Let's define that method. Private void backtrack, and what all do we need to pass? We need to pass our integer nums. We need to pass a starting index. We need to pass our current subset, so we can say list integer current subset, and similarly list of integer which is result, right? So that each backtracking result is added to the result list, right? Let's expand it this way. Now let's call this method, right? So we can say backtrack, and we'll pass nums, we'll pass the index 0 for the start, we'll pass current subset and result. That's it. In the end we can simply say return result. That's it. So just like the backtracking procedure, first we'll add the base case, which is the blank element, right? So we can say always add the current subset to the result. So each time when, let's say, we are going for forming 1 2 3 and we have formed only 1 will be added to the subset, then 1 2 will get added to the subset, then 1 2 3 will get added to the subset. So we can say result, right now it's blank, so result.add will add the blank subset, result.add, and we'll say new array list and current subset is blank as of now, right? Okay, now we are going to explore for all the possible subsets by iterating through the array. So we can say explore all possible subsets by iterating through the array. Okay, for int I is equal to start, we'll start from the start, and start will keep moving. So once we have finished with all the possibilities of 1, that would be just 1 alone, then 1 2, then 1 2 3, then we'll move the start pointer and we'll bring it to 2, then 2 1 2 3, then 2 1 3, but 2 1 3 is already covered, so we'll not take that, right? Okay, so we'll say I is less than nums dot length I plus plus. Okay, now we cannot form 2 1 3 because we are only moving in forward direction. So with 1 we'll form 1, we will get 1 2, we will get 1 2 3. So 1 1 2 and 1 2 3. With 2 we will get 2, that is this, and 2 3, that is this one. With 1 we will also receive 1 3, right? And with 3 we will receive only 3. Okay, so we'll say first we are going to choose the current one. So we can simply say choose current subset, that is the blank, dot add nums of I. Choose next element in the current subset. So let's say in the beginning we had blank, right? And now I am adding the first element, that is 1. So blank was already added to the result list. Now we have added 1, so that is 1. And now I'm going to start the exploration again with considering only 1 as the starting point. So we can say explore other possible subsets. So for this we call the backtrack. We pass the same array nums. Now starting index has moved I plus 1 and current subset, which is now 1, right? And result. Okay, now when this method is called backtrack, right now current subset contains only 1, and result dot add new array list current subset, so 1 also gets added, right? Then we start I is equal to start, which is 2, I is less than nums length, right? Current subset dot add nums of I, so 2 gets added. Again we call for backtrack, then backtrack brings us to this line of code and we add it to the current subset. Current subset is now 1 2, which gets added to the result list, right? And this way we'll get added all the next possibilities. Now once this method call is over, we'll remove the current added subset from the list, right? So we can say unchoose or this is actually called backtrack the last element. So we can say current subset dot remove current subset dot size minus 1. Okay, so simply since we added 1 2 and now we'll remove 2, we'll go with 1 3, so with going with different set of paths. We have seen this in all the backtracking solutions, that we always remove the last path that we had taken once the exploration is finished, so that we can now move towards next possible solution. Let's say the given array was 1 2 3 4. So one path is 1 2 3 4, next path is 1 2 4, right? So we backtracked from 3 and reached back to 2. So this way we remove the last element. Okay, yeah, that's it. We are returning the result already. It's a very small problem. That's it from this video, guys. Let's see. I hope we don't get any. There's always at least one compilation issue, I'm guessing now. RESULT. This does look correct, right? List of list. Okay, we missed this point. Let's run it and check. Okay, let's hope that was the only one. Okay, let's submit. And meantime, can you guys guess what is the time complexity? Why is it 70%? It's actually a very fast algorithm. Let me submit again. Let's see. It must be, oh, see, 100% of the users with Java, right? So, and since we are going to cover all the possibilities and remove the possibilities, the overall time complexity is going to be 2 to the power of n. So that's all from today's video, everyone. For anything, please let me know in the comment section. And in the end, please like, share and subscribe. Thank you.